In Learning Objective 7.3a, we're going to solve radical equations. An example of a radical equation would be something like the square root of x minus 4 equals 0. The square root symbol is considered the radical. The first step you're going to do is get the radical on one side of the equation if necessary. So for our example here, our radical is the square root of x, so we need to move the 4, so I'm going to add 4 to both sides. Be left with the square root of x equals 4. Step 2 is going to be raise each side of the equation to the, I'm going to say reciprocal power, and I'll show you what I mean by that, to eliminate the radical. So the square root of x is the same as x to the 1/2 power equals 4. So to get rid of the 1/2, I would do the reciprocal of that, which is 2 over 1. So I'm going to do 2 over 1, which is the reciprocal of that, and then 2 over 1 over here. That would leave us with x equals 4 squared is 16. And then in step 3, you're going to solve the resulting equation using techniques from previous chapters. And then the last step is going to be check your solution. So we did step 3 by doing 4 squared root of 16. Now let's just check the answer. I'm going to put 16 back into the equation for x, so that would be the square root of 16 minus 4. Does that equal 0? Square root of 16 is 4 minus 4 and equals 0, so we are correct. So if we apply those steps, again, the first step said to get the radical by itself, so the radical is the cube root of x, so to move the minus 2, I'm going to do plus 2. And I'll be left with the cube root of x equals 2. Then I'm going to rewrite the radical as an exponent. The cube root of x is the 1/3 power. Now to get rid of the 1/3 power, I'm going to multiply by its reciprocal, which is 3 over 1. So over here, this becomes x to the 3 over 3 power, which is x to the first, or just x. Right here, 2 cubed is 2 times 2 times 2 is 8. I'm going to circle the answer and just double check it. If I put it into here, the cube root of 8 is 2. 2 minus 2 is 0. Here's a few more problems for practice. We actually already did number 1 on the first slide, so let's just do number 2. For number 2, another way to look at it is isolate the x. If the x is right here, you need to move everything away from the x, and you work your way furthest and then work your way toward the x. So the plus 3 is the furthest out, therefore I'm going to move the plus 3 by subtracting 3. And I get it the cube root of x equals negative 3. Then I'm going to come on in, and this x is almost by itself, but I'm going to rewrite this as an exponent. So it's x to the 1/3 power equals negative 3. To get rid of the 1/3, I multiply by the reciprocal of 3 over 1. So what I have to do here is do negative 3 times negative 3 times negative 3, which will become negative 27. If you put negative 27 into here, the cube root of negative 27 is negative 3. That plus 3 is 0. Here's a more advanced one to take a look at, and I'm going to again take this approach instead. I find the x that we need to get by itself, which is right here. So if you look at it, there's 4 things we're going to have to do. We have to move this 3. We have to get rid of the radical symbol. We have to get rid of the 4, and we have to get rid of the negative 1. So there's 4 steps we have to do. What I'm going to actually do first is rewrite this square root as a rational exponent. So I'm going to say that this is 3, and then it's x plus 4 to the 1/2 power. Minus 1 equals 8. And it's almost easier to see this way. We're going to work our way toward the x, and the x is right here. So the last thing I'm going to actually do is get rid of the plus 4 because it's the closest to the x. And the second to last thing is going to be able to get rid of this exponent because x plus 4 is kind of locked in those parentheses with that exponent. So the only 2 things that I can maybe do first is either get rid of the 3 or get rid of the negative 1. Now the one that's the furthest away from x is the negative 1, so that is actually my step. So I'm going to add 1 to both sides, be left with 3, x plus 4, little 1/2 power, equals 9. Now again, x is right here. The 4 is locked into these parentheses. The 1/2 is locking it in there. The only next thing I can do is to get rid of the 3. This is being multiplied by 3, so I'm going to divide everything by 3. I'm going to get x plus 4 in parentheses to the 1/2 power is 3. Now the thing that's furthest out is the 1/2 power. To get rid of that, multiply by the reciprocal of 2 over 1. It's a little exponent. This is x plus 4 equals 3 squared is 9. Last step, we can do this one. Subtract 4 from both sides. X is going to be equal to 5. And they are going to challenge us to check the solution. So if you put 5 in for x, will it work? Let's just double check. 3 with the square root of 5 plus 4 minus 1, will that equal 8? Well, this will be 9. The square root of 9 is 3. So that'd be 3 times 3 minus 1. That does equal 8, so it confirms that I am correct. It's another nice one to try out. If we look at it again, the first thing I do like to do is let's take that radical symbol, which is the square root, or the exponent's 1/2, and let's rewrite it as an exponent. And I like to do that because it shows me that x plus 1 is locked in by that 1/2, so I know I'd have to move the 1/2 before I can actually move the 1. Then I have the minus 2 equals 3. To get x by itself, we're going to have to move this 1, the 1/2, and the minus 2. If you work your way furthest out and go towards the x, the natural first thing to do is to get rid of the minus 2. To get rid of minus, you add. Okay. Now you can tell that that 1 in x is locked in by the 1/2, so we've got to get rid of the 1/2. The only way to do that is the reciprocal 2 over 1. And again, this is a little exponent. So we have x plus 1 equals 5 squared, which is 25. Wrap it up by minusing 1. X equals 24. If we put 24 in for x here, this equation will work. Here's a different type to look at when we have two radicals separated with a plus or minus sign. It looks complicated, but it's actually pretty easy. Here's the trick. We have this radical here and this radical here. What you want to do is what step 1 suggested, is get them on separate sides, so one radical on one side. So I'm going to keep the square root of 2x there. I'm going to move this one right here, which is minus the square root of x plus 1. To move minus, I'm going to add, and I'm going to do it over here. Now I'm left with the square root of 2x is equal to the square root of x plus 1. I am going to rewrite that radical as a 1/2 power, and this radical as a 1/2 power. And everything is locked in by these parentheses. That's locked in there and that's locked in there. So the only thing I can do is get rid of the 1/2 power by multiplying by the reciprocal of 2 over 1. And when you do that, both sides free themselves up and the exponents drop out, and we are just left with 2x equals x plus 1, which we did at the first part of the school year. To solve this, I have to get the x's together, so I think I'll bring this x over by subtracting. And I get x equals 1. If I do put 1 back into the equation here, into here and here, I'd see what I would get. I would get the square root of 2 minus the square root of 2 equals 0, which is a true statement, and we are done. Here's another example like that one. So if you notice, we have one radical and another radical separated with a subtraction, or an addition sign would also be the same thing. I'm going to get them on two separate sides of each other. And I'm just going to show you this trick. Instead of rewriting the exponent or the radical to a 1/2 power, if we have a square root here and a square root here, by the way, I would come in and square both sides and they would cancel out. So I would just be left with this equation right here. To solve it, I think I'm going to, let's move the 3x over to the right. So I'm going to subtract 3x, leave me with negative 2 equals negative 2x. Then divide by negative 2, so x would equal 1. And if you check your solution on this, it will actually work too. The one last problem to look at is this equation here. The two radicals are already on separate sides, but you have to be very careful. And let me show you this. I am going to rewrite the radical symbols as exponents. So it's x to the 1/2. And this would be x to the 1/2 also. Now, they work the same in that I want to get rid of the 1/2 power. So I'm going to raise this entire side to the 2 over 1, and I'm going to raise this entire side to the 2 over 1. So when I do that, this side here, those just naturally drop out, so that's very clean. The left-hand side, you have to be careful. This 2 over 1 goes there and there. So it would be 2 to the 2 over 1, and then x, which is 1/2 to the 2 over 1. Clearly, the 1/2 and the 2 over 1 for the x cancels out, but careful, 2 squared becomes 4. So it's 4x equals x plus 3. To solve this one, I think I'll move the single x over, so I'll subtract x here. And then wrap it up by dividing by 3 on both sides, and I'm going to get x equals 1.